We're given a string that consists of 6 different characters, the opening and closing parentheses, square brackets, and curly braces. Given this string, we have to return true if the string is valid, and false if it's invalid. Now, the problem defines a string to be valid if it meets 3 conditions. Open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket must have a corresponding open bracket of the same type. So for example, something like this would be valid, but this would be invalid, since the open parentheses is being closed by a square bracket. So how would you approach this type of problem? Well, another way of phrasing this problem is that the last type of bracket that is opened must also be the first one to be closed before any others. So our strategy for keeping track of brackets should be a last in, first out approach, also known as LIFO. So now we ask, what data structure uses the LIFO principle? And the answer is a stack. So this is a pretty good hint that we should use a stack to keep track and manage all the brackets. Now let's look at the code and see how we can implement this in Python. Let's say this is the input string we are given. The first step is to create a stack, which I'll also represent with this diagram here. You'll notice that I'm actually declaring a list here, but we can use a list as a stack as long as we only operate from one end. So for this problem, I'll only use the append and pop methods to interact with the list. In the diagram, this side represents the top of the stack. In other words, the end of the list. Next, we'll create a dictionary called pairs that maps each type of opening bracket to its corresponding closing bracket. This is how we'll check that the brackets match up. We then enter a loop and use a variable called bracket to traverse it. So here's the big picture idea. If the bracket is an opening bracket, then this part will push it onto the stack. Otherwise, it's a closing bracket, so this part will check if it's the correct type of closing bracket. If it's not, then we exit early and return false. If we get to the end and all brackets have been properly closed, then the stack should be empty. Okay, now let's look at the example. First, this line checks if bracket is a key in the pairs dictionary. In other words, we're asking, is it an opening bracket? This is true here, so we'll just push it onto our stack using the append method, like this. Next, let's move on to the second bracket. Is this square bracket an opening bracket? It is, so we'll push that onto the stack too. Moving on, is this bracket an opening bracket? This one is not a key in the dictionary, so it must be a closing bracket, so we jump to the else block. We'll check for 2 conditions here, and if either of them are true, we'll return false. First, we'll check if the stack is empty. This is because, since we just encountered a closing bracket, if the stack is already empty at this point, then that means there are no more opening brackets left to close, which means that there is a mismatch and the string is invalid. If we look at the stack, it's not empty, so let's check the second condition. So first, we'll pop the stack, which removes and returns the bracket at the top of the stack, which is the opening square bracket. We'll then use this opening bracket to look up the corresponding closing bracket in the pairs dictionary, which is this one. We'll compare that closing bracket to the bracket that we're currently on in the loop. If it matches, like it does here, then this statement will be false, which means we just continue on with the loop. In other words, it means that this was the correct type of closing bracket. So the next bracket is an opening curly bracket, so we'll just push it onto the stack. Next is a closing parentheses, so let's pop the curly bracket off the stack and find the corresponding closing bracket. Now we compare the two, and we find that they are not the same. That makes this statement true, and so since we have detected a mismatch, we can return false immediately. The string is invalid. Now let's try a different example where we'll be able to get all the way to the end. We'll start off the same way by creating the stack and the dictionary. The first bracket is the open parentheses, so we'll push that onto the stack. Next is an open square bracket, so we'll push that on. And next we have an open curly bracket, so let's push that on as well. Next we have a closing curly bracket, so let's pop off the opening curly bracket off the stack and compare it with the current bracket we're on. It's a match, so we can move on. Next is another closing bracket, so again, we'll pop the stack and compare the closing brackets. This is also a match, so now we're done with the loop. Now for the last line of code, if all the open brackets have been closed, the stack should be empty and the length should be 0. But here, since there's still one parentheses left over, the length of the stack is 1 which makes this false. So the algorithm returns false. If this last line is confusing to you, you could also write it like this. If the length of the stack is 0, return true, else return false. It's the same thing, but the way I wrote it here saves you 3 lines of code. Now, what if this string had a closing parentheses at the end, which then would have made it valid? Well, if we rewind a bit, at this point of the loop, we would have had to do one more iteration for the last parentheses. We'd pop the opening parentheses off the stack, confirm that it matches the closing parentheses, then exit the loop. Now when we get to the last line, this expression evaluates to true, so the algorithm returns true. The string is valid, and we are done.